So, good morning. This is the first assignment that given to us. First, the introduction to electric signal modulation. Abstract. We are shown down sound of light waves, light waves walking bundle of frequencies turned into a cosmos. We are sold dressed up in scared biochemical garments in our bodies, our instruments through which our soul played the music, according to Sir Albert Einstein. This research is made to have self-understanding on the concept of how powerful and important to know the communication system in our living world. We all know that communication is the most essential need in order to keep in touch to other person. This is a helpful way to reach out persons far from us. But sometimes we cannot avoid the hindrance while making the conversation. To research, it is also aimed to give an enlightenment on how to make an action in the problems we are encountering during or before making communication. So in my introduction, for the instance, you have a crumpled paper in your hand and you throw it in a full strength that you have. I bet even you have the best shot of throwing the paper, still, it would not go so far. But how about you put a stone inside a crumpled paper and try to throw it? Then try to observe which method or which paper goes so farther. This example experiment that you made can be a theoretical applied in modulation. This research also aims to discuss on how our digital gadgets or appliances can be projected image, sounds, and even live feed videos. And this research also aims to appreciate the extraordinary discovery of our forefathers in telecommunication fields like Alexander Graham Bell, or also known the father of modern communication, who dedicated his life and built the first telephone. That later on, and scientists innovate a station over the great distance to a receiver. In a radio transmission, it is necessary to send audio signal, example, music, speech, images, videos, and etc. from our broadcasting station over the great distance to a receiver. This communication of audio signals does not employ any wire of this, sometimes called wireless. The audio signal cannot be sent directly over the air of applicable distance, even if the audio signals are converted into an electrical signals. The latter cannot be sent very far without employing large amount of power. The normal voice signal of human voice can consist of frequency of 3 Hz of spectrum that may vary to 20 Hz to 200 Hz. Before we go deeper, we should go first know the terms that we are using. So this is the definition of terms that we will be encountered later on. First, the amplitude, the maximum departure of the value of an alternating current wave from the average value. So amplitude, it is where the power of a specific signals can be thrown or can be the high peaks or the power of the frequencies. Modulation is the process of converting data into a radio waves by adding information into an electronic or optical carrier signal. A carrier signal is one of the steady waveform consists of height or amplitude and frequency. So modulation, it is where transmission of data which from electronic to digital. So frequencies, the number of repetition of periodic process in a unit of time. Spectrum, a set of colors into which beam of light can be separated. A range of waves such as light waves, radio waves, or radio waves. So spectrum, it is where if we're gonna convert it on how does the frequencies range, or let's call the bit of range, the highlight and bit of range when it comes to colors. Bandwidth, a range of frequencies occupied in a modulated frequency signals usually given in hertz cycle per second, or on a percentage of radio frequencies, for example an AM or amplitude modulation broadcasting station operating at 1000 Hz as bandwidth of 10,000 Hz or 1%. Or 10,000 to 1,000. The term also designated a frequencies range an electronic device such as amplifier or filter will transmit. Sinusoidal, a mathematical curve defined in terms as sine, trigonometric functions, or pitch of the graph. This is type of continuous wave and also a smooth periodic functions according to Wikipedia. Background. The communication system is a system which describes an information exchange between 2 points. The process of transmissions and the receptions of information is called communication. The major element of communication are transmitter of information, channel or medium of communication, and the receiver rather, of information. So they are the three essentials in communications: the transmitter, the channel or the medium, and the receiver. Telecommunication science and practice of transmitting information by electromagnetic means. Modern telecommunication centers problems involved in transmitting large volumes of information over a long distance without damaging loss due to its noise interference. So, we will know what is interference later. A number of modulation techniques have been proposed, truly analyzed in literature optical wireless communication system. Each modulation technique has a unique attractive features as well as its challenges. So these are the benefits of modulation, or this is the benefit, yes, of modulation. The height of antenna is reduced in interference among the signals, mix of signals and reduced multiplexing of signals is possible. Long distance communication is possible. So we will teach you on how to calculate the height of antenna, because here we can see the height of antenna is reduced. So if you have a television or any gadgets that needs an antenna, this is on how you calculate the height of your antenna. For a while. So this is how you're gonna calculate the antenna size if you have antenna. Just bear in mind that length is proportion. This is the sign of proportion to the wavelength. So that is the variable for wavelength as well. So first, this is the variables that we are using. Can be c, or the speed of light is equals to 3 by the power of 3 by 10 to the power of 8. milliseconds. So we're gonna use for an F variables for frequency. This is the symbol of wavelength. So we're looking for the length of the antenna that we are desired to build up. But first, if you want to try to calculate the speed of light, this is the formula. So C is equals the wavelength multiplied by frequencies. So for an example, we have the length of example we have the length is equals to wavelength. Example we have 4. If you have a 4 frequencies is equals to, if you're gonna try to get the length of antenna is equals to frequencies is equals to, for an example we have 10 kilohertz. So if you are in the area of have 10 kilohertz, how are you gonna build up antenna, an antenna that can be suited for 10 kilohertz in your area. So as we speak, we're talking or we're looking for the length of antenna. So wavelength is equals to divide the speed of light to the frequencies. So it's equals the speed of light would be 3 by 10 with the power of 8. So this is the standard equation of speed of light. So we have a frequency of 10 kilohertz. So we have 10 kilohertz with the power of 4. So it will get 10,000 kilohertz. So it will try to calculate. We have the solution of wavelength is equals to 3 30,000. We have 30,000 meters over. Oh no, we have already 30,000 meters. So we have 4 here. So 30,000 divide it to 4. Where do we get the 4? Example of the length of a meters. You have 4 meters. So we have wavelength is equals to 7,500. Still, 7,500 meters still quite big, right? We cannot produce 7,500 meters for only just an antenna, right? So we can call it also an impractical size of antenna because we cannot do such 7,500 meter. How much more 30,000? So we will just reduce it. So how to reduce 7,500 meters? So we use the formula equals frequency is equals to, we have 10 megahertz if the length of antenna that we're looking has 7,500. So 10 Because it's thousand, you just need to move the significant decimal to the left because it is thousand. So we will have 7,500 meters. So you have 7.5 meters if you have the frequency of 10 kilohertz down to 10 megahertz. So that 10 megahertz is suited already for your 7.5 meters antenna. So, thank you. So that's how you calculate the height of antenna. Reduce the interference among the signal. Wait for a while. Okay. We'll discuss the interference. What is interference? Interference, it is where, for example, you are talking with your mom. Then suddenly your sister came up and talked as well with your mom. So you have an interference. Your mom didn't know which which is she gonna cater or she gonna listen first. For example, let me have this one. So for example, we have, as what we've said, we have transmitter, the channel, sorry, the channel, and the receiver. So for an example, transmitter, as what I've said for an example a while ago, transmitter is you. You or yourself who's talking to your mom. Your mom will be the receiver. And the mode of channel is your communication. So your communication. Example, you are talking to a cylinder a cylinder a cylinder tube. You're talking there. Then there is someone who is listening at the other end. So this will be your transmitter, the tube will be your channel, and the listener will be your receiver. But how about if you have both five of you, five of you, or three of you? Are the receiver or the listener will gonna clearly listen if these three person will talk um will talk not one by one, or will talk all of them will talk. If these three person all of them will talk, are the listener gonna listen carefully, or each of them, or which may be much good or better if both of them or each of them have a tube? For example, if all of them have a different tube, then they're gonna speak by um, alternating. They're gonna they're not gonna speak in chorus. That's the right term, chorus. If they're gonna speak in chorus by one tube, I don't think so that the listener or the receiver can perceive the message correctly. But if they have the different channel and they're gonna speak alternately, the receiver will gonna receive their message carefully. So the interference here is someone who are not in line, or someone is not inbound in your channel. So that's it. If ever the third person try to speak chorously with the first person, it is not inbound on his channel, then the receiver will not directly know the true message or which message are the receiver gonna cater first. So that is the interference. So multiplexing, it is still like an interference. So it's just like tampering. You speak chorously. So multiplexing. But here, the benefits has a multiplexing of signals. Why? Because the higher the modulation, the higher uh, the higher tendency of catering of a lot of receivers. So multiplex means multi or many. But if the transmitter will be the one to uh, speak multiple, it is called tampering. So, modulation by analog signals refer to the process of transferring an analog-based or low-frequency signals like an audio or TV signals over a higher frequency signal such as radio frequencies band. There are two types of modulation of radio frequencies carriers. It is the amplitude modulation and the angle modulation. The amplitude is the carrier signals made follow that is modulated signals. As is noted, the analog to digital conversation, voice signals, as well as the audio and video signals are inherently analog in form. In most of modern systems, these signals are digitized prior to transmission. But in some systems, the analog signals are still transmitted directly without converting them to digital form. There are two commonly used methods of modulating analog signals. One technique is called amplitude modulation, varies the amplitude of fixed frequencies carrier waveform in proportion to the information of signals. The other technique is called frequency modulation, varies the frequency to a fixed amplitude carrier wave in proportion to the information signal. Amplitude modulation. Amplitude modulation is a form of AM. It is also the earliest modulation method that used in the transmitting information over the radio. This technique was devised in 20th century, a time when Landel, De Moura, and Reginald Passenden were conducting experiments using radio telephone in 1900. After successful attempts, the modulation technique was established and used in electronic communication. In general, amplitude modulation definition is given a type of modulation where the amplitude of the carrier wave is varied in some proportion with respect of modulating data and signals. As for mechanism, when amplitude modulation is used, there is a variation in the amplitude of the carrier. Here, the voltage of the power level in the information signals change in the amplitude of the carrier. In the AM or the amplitude modulation, the carrier does not vary in amplitude. However, the modulation data in this form of signals component consisting of frequencies either the higher or lower than of the carrier. The signals component are known as sidebands, and the sideband's power is responsible for the variation of the overall amplitude of the signal. So this is the amplitude modulation. So, as what I've said, if the AM, the analog signals is constant, so this is the waveform. The waveform or the frequencies will varies on the waveform of modulating signals or the amplitude of the signals. Example, we have this waveform. So in our if we're gonna try to see on our oscilloscope, this is the device used to measure or to know the frequencies of signals. If we have the amplitude curve like this, the frequencies will curve as well on what amplitudes is given. So that is the amplitude signals. Frequency modulation. Frequency modulation is a modulation in which the frequencies of carrier waves is altered In accordance with the instantaneous amplitude of the modulating signals, keep on pacing an amplitude constant modification of carrier wave frequencies is formed from the purpose of sending data informations over a small distance. Frequency modulation's index is constantly over 1, requires with high bandwidth in a range of 200 kHz, operates in very high frequencies range of 88 to 108 MHz, has a complex circuit with an infinite number of sidebands and receive a high quality signals with high sound quality frequencies. And phase modulation are complementary principle method of angle modulation, which is class of carrier frequencies modulation often used in telecommunication transmission system. A frequency modulation refers to using an output of a low frequencies oscillator to continually alter modulate frequencies with another oscillator. This example provides the user control and amplitude and frequencies both are carriers. The oscillator and the we are heard directly with a modulator oscillator, the effect of which heard directly. The output of modulating oscillator is added constant. The main frequency, those causing the carrier frequencies, structured with down and central frequency. So this is the frequency modulator. As we can see, the modulation waveform is going sinusoidal or this kind of waveform. So the frequencies are the distance of frequencies are also varied. For example, let's try to look at this. As you can see, the distance of the frequencies are compact, but when this line, but when on this line, on the center of the wavelength or the modulation, reach the high peak and going down, the distance of frequencies are also scattered already. So if the range of modulation are going high, the frequencies distance are being compact. Well, if it's going low, the distance of frequencies are loosened as well. So that's the frequency modulation. Phase modulation. A phase of carrier wave is varied in response to a vibration of a sound source in phase modulation or PM. This form of modulation is often considered as variation of FM. Two processes are closely related because the phase cannot be changed without also varying frequencies, vice versa. Also, the rate of which phase of carrier change is directly proportional of frequencies in audio signal. So this is the phase modulation. So as you can see, if the wavelength of the waveform is just like this, when it comes to this peak, then going down, the phase modulation will alternate this waveform going down as well. So if the waveform goes on its peak, the phase modulation is going constant. Then it's just like mirroring on the waveform of frequencies. Modulation by digital signals. In order to transmit computer data into a digital information, a communication channel analog carrier wave can be modulated reflect by binary nature and digital baseband signals. The parameters of the carriers can be modified the amplitude by frequencies and phase. Amplitude shift keying. Amplitude is one of parameters of the carrier waveform. To be altered information signals, the modulation is called amplitude shift keying or ASK. Can be considered as digital vision of analog. Amplitude modulation is the simplest form of burst of radio frequency. Is transmitted only when binary 1 appears and its stop on zeros appear. In other variations, zeros and 1 are represented in the modulated signals by a shift between two well-selected amplitudes. For example, this is binary. This is the waveform of binary. It is just a square wavelength. Rather than this is the amplitude modulation. So if we're gonna try to convert this modulation to this wavelength, try to look at the sequence or try to look at the image. If the frequencies are compact or modulated, the waveform of the digital or ASK also um, affected or getting high by its by its um, by its peak as well. So if there's no signal, still it's constant. But if the signal or frequency is adapted, it also varies. So that is the digital or ASK. Frequency shift key. A frequency is a parameter chosen by functions in the information signals. The modulation method is called frequency shift key or FSK. In the simplest form, FSK signals digital data transmitted using one or two frequencies, whereby one frequency is used transmitted a1 and over frequency transmitted a 0, such as a scheme used in a Bell of 103 voice band modem introduced in 1962. To transmit information and rates up to 300 bits as per second over the public switch telephone network in the Bell of 103 modem frequencies of 1080 plus over the 100 Hz and 1075 over the 100 Hz as well. We use this send binary in data bus direction. So this is the frequency. Here in modulation, we are dealing with the waveform. If the waveform are high, we can count it as 1 because it is on the high peak. If the high peak of the frequencies is high, we can count it as 1, and if it is stable, we can count it as 0. So this is the high peak or the modulation or the AM or the ASK. While in frequencies, we varied on the wavelength of our signals. Example, look at this. These signals um, are neutral, while when the signals interrupt or when the signals are inputted, the spacing between the signals are compact. It varies or it can be represented in a digital form as 1 because it's compact. When it's loosened or it has a distance between the wavelength, it is going to neutral. So the higher the compact of the frequencies, the longest squaring of representation in digital in FSK or frequency signal or frequency shift keying. So in phase shift keying, when phase is a parameter altered by information signals or method called phase shift keying or PSK in the simplest form. The PSK single radio frequency is sent on a fixed phase represent a 0, and with 1080 degree phase shift that is with the opposite polarity to represent a 1. PSK are employed in a Bell in 212 modem, which was introduced in 1980 to transmit information at a rate up to 1200 bits per second over the public switch telephone work. So in phase shift keying, as we can see here, if the frequencies or if the frequencies signals, say this is constant or the neutral, when the frequencies are disturbed or inputted, it is counted as 1. Then why is that? Even though here are the frequencies are still moving in the digital form, it goes back to 0. It's because the what you call this one? The subdivision, which is called the subdivision of the frequencies, ends up here. Try to zoom in. Ends up here. So the varied subdivision of this kind of frequencies varied in this or occur as well in this as next pacing, so that the end point of the phase shift keying will be this end as well, because this will be the first lower term of modulation of frequencies, then it will vary to the next lower term of the frequencies as well on the next digital form of phase shift keying. Even though after this lower frequencies of the first subdivision of this phase are still moving, it still will go in constant. While after that, if these frequencies reach the peak of the first subdivisions or subdivision of frequencies reach the peak as well, so it will start going higher as well. Then it will end up to the lowest peak as mirroring on the first division of the frequency. So it will stop here because the peak of modulation of frequencies are the lowest peak of the modulation stop here. So the second phase will stop here as well. So next, bandwidth, occupancy in digital modulation. Emerging technologies as use spread spectrum of frequencies, hoping signals may enable more efficient use the high frequency or high frequency band with high power frequencies. Radar an example of technology where the channels are used to appear and to be reported in frequencies. Hoping signal of high frequencies radar had been remarkably free from interfering with the conventional spectrum. Occupants radio frequencies issued on issued 5 September October to 1997. Bandwidth is a precious commodity, hence in importance quality of frequencies occupancies commoditation signals. This is the end of considering a complex envelope of linear modulation signals. The two-sided bandwidth at a complex envelope equals physically bandwidth with the corresponding passband. Live on-demand video streaming service system consumes significant proportion of internet traffic all over the world. The HTTP, adaptive streaming, becoming a de facto standard for adaptive video streaming solution conversional estimation scheme. For bandwidth, an estimation is not appropriate an estimate of the bandwidth when multiple clients compete for a common bottleneck link. Due to on and off of traffic patterns, they overestimate the network bandwidth, which lead to degradation of quality of experience and unnecessarily change in video quality. Average video quality is unfair of a video quality proposing receiver side. Bandwidth measure method achieve a better quality experience on multiple clients scenario. The proposed method of estimate obtain an bandwidth based on the supper of status of segment of true output. So it's just a uh, uh, simple concept of bandwidth is inserted in the frequencies. As you can see, if you are going to watch a video of YouTube, it has a specification of quality 740, 740, 740, 100, 1080, 1080 pixels. It is on a pixelate bitrate where the bandwidth is inserted. Example, you are far from or far away from the commodity of transmission. So Expectedly, the bandwidth that you will receive is not totally high quality. Why? It's because the bitrate or the bandwidth inserted in the frequencies inside the transmitter are not fully packed or cannot be reached too much on your end because you're too far from the signals. So that's why sometimes we will encounter blurry videos or bitrate in our videos because of the bandwidth. If the bandwidth or the channeling of bandwidth are become thinner or become lessened, the video quality of our the videos that we're watching getting affected. That's why even though you are in high quality performance of your video, when the bandwidth is affected directly, then your video will adopt the very low quality such as 360 megapixel. So it is on a pixelated form as well on your YouTube. So that is bandwidth. Spectral response of encoded data. A response spectrum functions frequency period showing the peak of response of simple harmonic oscillator is subject to transient even response spectrum is function of natural frequency on the oscillator. It is damping of those. This is not direct representation of frequency convent of the execution of foreign transmission, but other effect as signal postulated system with a single degree of freedom. Spectral response of encoded data. This is which how the data is can interpret by spectrum. What is spectrum? It is a waveform of light, but in our case, we are on the sound waves. So uh, the spectrum of the data, if the amplitude is like here, then the harmonics of the frequencies are will be represented on spectrum, the high peak, just like this. If the light waves can be determined as well in the spectrum, also in the waveform, once the frequency is entered on the or inputted, the spectrum will also represented. Example, let's put in this here. You have, for example, um, because we are in the sound waves, let's say the vibration, or let's say the perfect term is water. Example, for a calm water or a calm water here, um, example, it is a tub with a calm water. Once there is a ball drop here in the center, the spectrum or the waveform of water, or there will be created wave occur when the time the ball hits the center of the water. So this wave are from the distance of the ball to the wave, that is the spectrum of the digital representation. So that is the spectrum. Anyway, I would like to um, go back to the basic one. Example, we have a transmitter here. This is how we transmit wireless. Example, we have a transmitter here. Say we have a very big transmitter here. Then this transmitter can produce 10,000 kilohertz per second. So the magnetic wave that can produce of this telecommunication is 10,000 hertz per second. That's why we have banding in our radios like 107.1, 107.2, because the channel that they buy on the market is that kind of broadband or that kind of channel. As what we've said, we have transmitter, we have the channel, and we have the receiver. So, example, 10,000 hertz, 10,000 kilohertz. 10,000 kilohertz per second. So, uh, the electromagnetic atoms or on that particular area, example, it is in the air. It is in the air, spread in the air. Then, each atom has already a data inside of it. Example, you have a radio, you tune your radio in 107.1. 107.1. So, this 10,000 kilohertz, once it was triggered, the electromagnetic waveform, will spread out these particles in the air. Then, if you have a channel of 107.1, because it is under on the 10 kilohertz, the 107.1. If you have a channel of this channel, example, of 107.1 radio, example, all the data specifically received by your channel will go to your receiver. That is the concept of telecommunication. Okay? So, this telecommunication is also a radioactive somehow because it produces magnetic wave that can cause our body cancerous. So that is the basic concept of telecommunication. Moving forward, spectral response of the carrier frequencies before modulation. A sine wave, sinusoidal wave are most natural representation of how many things that nature change. State, since waveforms show how amplitude variables change with time, and variables could be audible sounds. Example, a single pure note is a sine wave that although would sound very plain, flat note indeed note in harmonic we normally hear in nature a straightforward alternating current or voltage within the wire, but also represented by a sine wave. This number of times sine waves goes through a complete cycle of space of 1 second is called a frequency. Indeed, the unit of used to be cycle, sine waves goes through 1,000 complete cycles. If we are considering audible sound waves, then the human ear has frequency range of about 20 Hz to 20 Hz to 20 kHz. Since the frequency is constant, its spectral response is located on the horizontal axis. The peak voltage shown as a vertical axis corresponds the bandwidth is 0 figure in 1.8 below. So this is the sound wave before the carrier frequencies before modulation. Spectral response. So as you can see, when you are calling someone, there is what you call channeling first. So that channel are the carrier frequencies before modulation. Then after that, if the bandwidth or the spectral frequency are inputted in the frequencies, it varies on the tune on the other end. As example, the normal voice of a human is 20 kilohertz, 20 hertz. But when you go to a telephone wire or a telecommunication, it changes somehow. The voice of somehow it changes the voice because before the transmitting in the inside of the transmission of the frequencies, somehow the bandwidth are changes. The spectral response or the waveform response changes. For example, This is calm water. You are the receiver. You drop the ball. You drop the ball. So there is a spectral waveform. As you can see, the farthest that goes of the spectral waveform it's not just only one waveform or wave that can be created, right? So the farthest, the data will also changes. So before the spectral waveform, you as a human or you as a transmitter, your voice are not yet modulated. At the same time, not yet amplified. It's normal. But when it goes to spectral waveform, it changes. So the receiver somehow hear your voice murmuring or somehow kind of digital. So that is the data on that spectral are changes as well. So that is spectral response carrier frequencies before modulation. ASK bandwidth at a glance. Where the baseband signals modulated amplitude of the carrier signals, the process is called amplitude modulation. For digital baseband signals is called amplitude shift keying, as we talked earlier, as also referred as PMA or pulse amplitude modulation. Amplitude shift keying is a form of digital modulation that represents digital data solely as a variation of amplitude that carrier signals. In ASK, the amplitude of the carrier signals is changed between two or more levels by the digital information message signal. MT to represent the binary zeros in the carrier signals center frequencies or FCS phrase C remains constant for the binary. ASK, BSK binary digits are presented the carrier signal at a constant amplitude during the bit period while binary zero. So this is the binary glance amplitude shift keying. Segment 1. 1 signal element. Segment 1 signal element but TB goes to 2B. This is 3B for TB. So implementation. So R equals to 1, S is equals to N, B is equals to 1 plus D to S. So this is what we call bit rate. Bit rating. So implementation of binary in ASK amplitude. So as we discussed earlier, this is constant. Then the end of subdivisions, the ASK signals will also end in subdivisions. Then the carrier signals changes, then it changes as well. Why is that carrier signals are just same frequencies? It's because it's somehow the channel. It is where the frequencies can be get. Bitrate. Bitrate. The frequencies can be get. This is the time. Or the channel as well. Okay. FSK bandwidth at a glance. In frequency shift keying, carrier signal frequencies is illustrated binary 1 or 0. The frequencies of signals during each bit period is constant and its value based on bit 0 or 1. Both peak amplitude and phase remains constant. FSK bandwidth at a glance is spectral response of NZR data before modulation. B spectral response of modulation, spectral response after the modulation. So this is the representation of carrier frequencies before modulation or FSK bandwidth at glance. So what can we notice here? So as we expected, the FSK or the frequency shift keying are noticeable here to A to C. Same with the ASK, the carrier frequency signals are the medium. So when it comes to when there is a disturbance between the frequencies or gap between the frequencies wavelength or distance, it also presented in the data. So that is the glance. BPSK bandwidth at glance. Binary phase shift keying is a two-phase modulation scheme where the zeros and one is in a binary message represented by two different phase state and the current signals the sign of binary and 1 and sign of 180 degrees binary zeros in digital modulation techniques. A set of basis functions are chosen in a particular modulation scheme. Generally, the basis function orthogonal to each other. Basis function can be derived using Gram-Schmidt orthogonalizational procedure. Once the basis functions chosen in a vector in the signal space can be represented in a linear combination of them. In binary or BPSK, only sinusoid, it is when the basis function modulation is achieved verifying phase and sinusoidal depending on the message bit. Therefore, within a bit duration, time over bit rate. This table shows the number of phase and corresponding bit per phase for modulation scheme. For M is equals to 2, 4, 8, 16, 32, and 64. Each will be shown at the higher order for MPSK modulation scheme. M is to less than to 2. They are spectrally efficient. So these are the table of specification of the bitrate. So that will be the last slide that I have. So thank you for listening and have a great day.